Hello students, today we'll start the IPv4 address, its notation and IP address classes. So in the last video we have completed the internet protocol and its datagram and the datagram header format. So in that header format we have seen that IP addresses, source IP address, destination IP address. So today we'll start from the IPv4 addresses. What is that IPv4 addresses? Basically, IPv4 addresses is identifier used in the IP layer of the TCP/IP protocol suite to identify the connection of each devices to the internet is called the internet address or IP address. Like whenever we are connecting our system to the internet, our system is getting some IP address. If you will go to your system and check your system IP address, you will find some IP address 192.68.1.1, like this you will find IP addresses. So basically it is this IP address is used to identify the system, each system connected to the internet, and it's a unique address. So IPv4 address is a 32-bit address which is unique and universally identifies the connection of a host or a router to the internet. And next is notation of IPv4 addresses. How we will notate that IPv4 addresses, or how we can represent that IPv4 address. So you can represent that in dotted decimal format or binary format or hexadecimal format. If you are representing in dotted decimal format, then the notation will be, or representation will be look like this: 172.16.254.1. If you are representing in binary format, then it will be like this. The 172 will be represented in respective binary representation, and then 16 will be represented its respective binary representation, as well as all the decimal numbers will be represented in binary format. The decimal digits will be separated by a dot, but the binary numbers will be separated by a dot, as well as it can be separated by a space also. This IPv4 address is divided into two parts. The first part of the address is called prefix, which is used to define the network ID, and the second part is called the suffix, which is used to define the host ID. The length is n bit and suffix length is 32 minus n bit. So now we will go to the classful addressing. We know what is that IP address. Now we will divide the IP address into different classes. So why we need to divide this IP address into classes? So we are basically dividing into 5 classes: class A, class B, class C, class D, and class E. So what is the necessity of this classification? Because we have different type of organization in this world. If it is very large organization, so the number of system is more, then it requires more host ID. And if it is a medium size organization, then the user is compared to less to the larger organization, so it required comparatively less IP addresses than the large organization. Similarly, in the smaller organization requires less IP address. So for the requirement of the organization, the IP address is classified into subclasses, that is class A, class B, class C, class D, and class E. Then each class has a valid range of IP addresses. The class D and class E are reserved for the multicast and experimental purpose only, and the other A, B, C is used by the organization. So let's have a detail on the classes. So the IPv4 address is divided into two parts. One first is host ID and another is network ID. That means the first part is network ID and the second part is host ID. So whenever we are representing the IP address, see here every digit you can count, it will be 8 digit, 10101100, here 00010000. So every binary number is 8 bit, dot 8 bit, dot 8 bit, dot 8 bit. That means each part you can say it's 8 bit or 1 octet. That means in IP address we have 4 octet. This one is first octet, this one is second octet, and this one is third octet, and the last one is fourth octet. That means each unit we can tell as 1 octet. So come here. So when we divide class A, class B, class C, class D, class C, in the class A, first 8 bit is, that is network ID, and the rest is for the host ID. That means total 32 bits. From first 8 bit we will get the network ID. That means how many network IP address we can get here. We will get here 2 to the power 8, but here in the class A we have some prefix. That is one value is already there, prefix value, that is 0, which is predefined, it's already set. So apart from that 8 bit, one is already predefined. So rest is 7. So how many addresses will be there? That will be 2 to the power 7, which is equal to 128 addresses. That is network addresses. From that, 2 addresses is reserved. So we have how many classes we can use as a network ID? That is 126. So the IP address will be starts from, see here, let me clear here in the explanation. So see here the class A, we can divide the class A into 32 bits. First is 8 bits and then is 24 bits. 8 bit is network ID and 24 bit is host ID. Here first 0 is the prefix and the remaining, how many bits is there? 7 bits. So 1, 2, 3, 4, 5, 6, 7. That means 7 0. We'll start from 7 0 and then 0 0 0 0 0 0 1 till all the numbers are 7 ones. We will do like this. From that, if we'll start the address, then address that 0.0.0.0 and the last address is 127 dot 255 is reserved classes. We cannot use that. Apart from that, any classes in the class A from 1.2 till 126 dot x you can use. That is the class A. Next come to the class B. Here look at the class B. We have first 16 bit is network ID and then the next 16 bit is host ID. That means how we can calculate how many network ID we can find in the class B. That is 2 to the power 16. That it will, whatever the value will come, that will be the network ID, and the host IP address will be 2 to the power 16 again. So in the class C, like in the class C, network ID is 24 bit and host ID is 8 bit. That means 2 to the power 24 is network ID in the class C and 2 to the power 8 is host ID in the class C. In the multicast address, that class D and class E is the reserved classes. And what is that prefix value? In the class A, we have one prefix value, that is 0, and in the class B we have another prefix value, that is 10, and in the class C we have prefix value 110, in class D it's 1110, in class E it's 1111. Based on this prefix, we can find the ranges of the IP address. From which range to which range we can represent in the class A and in the class B, class C, class D and class E. In the class A, the range of IP address will be from 0 to 127. In the class B, it will be from 128 to 191. In class C, it will be 192 to 23. In class D, it will be 224 to 239. And in the class C, it will be 242 to 55. So how we can decide this range? So let me explain you here. So we have already told in the class A, the network ID is 8-bit longs and the host ID is 24-bit longs. So let me calculate here, and for the better understanding of you, that is, in the first class A, first bit is prefix, and apart from that 8 bit, 1 bit is prefix and remaining is 7. So 2 to the power 7 minus 2, that is 128 minus 2, which is equal to 126 network ID. And the first and last address is reserved. The IP address belong to the class A ranges from 1.x.x to 126.x.x. Similarly, in the class B addresses, the network ID will be 16-bit long and the host ID will be again 16-bit long. Here in class B, we have prefix number 10. So in the first octet, we already reserved 2 bits, that is 1 and 0. So remaining is how many bits? It is 6 bits. So here see, in the class B, so we reserve the bit 10 is prefix bit, and remaining another 6 bit is here. From this 6 bit, it will start from 60 to 6 ones. Last address will be all 6 ones. So all 6 ones means 2 to the power 6. 2 to the power 6 is equal to 64. If you will calculate that last range of class A, what is the last range of class A? That was 0 to 127. If you will calculate 127 plus 64, so what will be the value it's coming? 191. That means the end address of a class B will be 191. So it will start from 128 and it will end with 191. So see here, in the class B address, so first 2 bit is prefix, that's why 2 to the power 14, which is equal to 16384 network addresses, and the host address will be 2 to the power 16 minus 2. That means from that always 2 host address is kept for reserve purpose, for the emergency or reserve purpose. So 2 to the power 16 minus 2, which will be 65534 host addresses. So you should not confuse with the network address and host address. What is that host address? Host address is the computer address. Whenever you are connecting from your system to the internet, that is your host ID or your host IP address. And network means which network you are connecting. That range is the network IP address, which is given by the ISP, Internet Service Provider. So then what will be the range of class B? So class A we have starts from 0 to 127. Class B will starts from 128 to 191. So the IP address will be 128.0.0.0 and it will end with 191.255.255.255. So let's come to the class C. In the class C, we have seen here in the class C, first 24 bit will represent the network ID and the last 8 bit will represent the host ID. So what will be the total number of network ID and total number of host ID in the class C? So in the class C, our prefix value is 110. That means 3 bit is already reserved and the remaining is 5 bit. That 5 bit we can represent here. It will start from 50. First 3 bit is reserved and then it will start with 50 and it will end address will be 51. So what will be the last addresses? So 2 to the power 5, which is equal to 32. We start with the address 192 and we'll calculate here the end address. That means 191 plus 32, which is equal to 223. So in the class C, the range will be 192.0.0.02 223.255.255.255. So come here. So as the 3 bit is prefix bit, so it will be 2 to the power 21. We have 24 bits of network address. So 2 to the power, it should be 2 to the power 24. But as we have 3 bit prefix value, so 3 will be subtracted from the 24. The remaining value is 21. So 2 to the power 21, which is equal to 2097152 network addresses. And what will be the host addresses in the class C? So it will be 2 to the power 8 minus 2, which is equal to 254 host addresses. IP address belongs to the class C, ranges from 192.0.0.0 to 223.255.255.255, which I have already shown in the below calculation. So now comes to the class D. In class D, how many prefix bit is there? We have 4 prefix bit is there. 1110. So the remaining is 4 bit, that is 0000, that is the starting, and the last address is 41. If we put that 41 to the 2 to the power 4, how much it's coming? 2 to the power 4, which is equal to 16. So whatever the last address we got from the class C to 23, we will add that 16 to 223. 223 plus 16. That means 239. So class D address will start from 224 to 239. That address will be 224.0.0.0 to 239.255.255.255. The class D doesn't possess any subnetting mask and the IP address belongs to class D is always reserved for multicasting and this cannot be used by any other organization. So last one is class A. The class A is also reserved for the experimental and research purpose, and as we are end address is 255, so we ended the class D here 239. So we'll start here from 242 till 255. So the range of the class C IP address will be from 240.0.0.0 to 255.255.255.254. This class doesn't contain any subnet mask. So this is the complete topic of IP address, and that is classful addressing or IP address classes. So we have completed here. So for more details you can go through the note here, and you have one assignment for you in this. So I have given here one assignment. So I have given some few IP addresses, 1 2 3 4 4 IP addresses. You need to find out each IP address is belongs to which class. I have already given the ranges. If the IP address will be in that range, that is from 1 to 126, then it will be in class A, and class B, class C, class D, class E. So I have already defined the ranges. So you need to find out this IP address belongs to which class of IP address.